Hello friends, myself Professor A.T. Motiani. I am Associate Professor at Early College, Morbi, and this is the fifth lecture for the topic of building planning for the subject of elements of civil engineering of GTU semester 2. So in this lecture series for this building planning, we have already covered the 4 sessions. The first 3 sessions were pertaining to we have classified the different types of building, then the different principles of planning. Then in the previous session, we have started with the drawing, because drawing is the important tool of communication for any component or structure or any building which is to be constructed. We have to explain that the different parts, details, size, material to the other stakeholders, maybe the engineer or designer or the valuer or structural designer. So this drawing is very important. We have seen in the previous lesson how the drawing is important. Without drawing we cannot construct or manufacture the equipments or the buildings. Then what are the different aspects of the drawing, that also we have seen in our previous session. And what are the different tools, how those tools are used, even though you are conversant with some of the tools at your school level, but some different engineering drawing tools are here used for preparing the engineering drawings. How it is this engineering drawing, how it is different from the artistic drawing, that also we have discussed. And what are the different conventions with, that is the symbols, or how the lines are drawn, what should be the thickness of the line, what should be the layout of the different drawings in the drawing sheet, what are the different size of the sheets, what are the different size of the boards, then which are the different types of the drawing pencils we have seen in our previous lecture. Then we have discussed what is the scale, which type of scales we have to use. Then what is the importance of the north direction, title block, margins, then the symbols of the materials in the section. When the component is being cut by a plane, maybe the vertical plane or horizontal plane, that is called the section, then we have to show the type of the material used in that particular component, maybe for the brick masonry, for the stone masonry, wood, glass, then the earth, different type of materials we have to show. And then we saw the different type of doors, windows, and how they are shown in the drawings. So different types of the symbols for different openings. Then the last was which we used this so last in our previous session we have seen this symbols for opening. So symbols for the openings, we have this single shutter door, double shutter door, swing having inside only, and swing having the inside as well as outside also. Then the revolving door, rolling door, sliding door, stair, then window, then cupboard. So then we started with this water and drainage plumbing symbols. So these symbols like this bath, then foot bath, bidet, shower, pedestal, wall lavatory basin, sink, tub set, slope sinks, combination, WC low down, WC means water closet, then urinal wall hung, urinal corner hung, urinal stall. So all these symbols you have to remember because they are universally everywhere. The same symbols are used for this appliances or the fixtures or the appurtenances which are used in the plumbing. Similarly, for this electrification and electrical appliances, these different symbols are used. Otherwise, this whole photograph of the refrigerator or the ironing machine or this pump, we cannot draw the complete figure of that. Instead of that, we are having this simpler symbol which shows like this pump is there. Okay, so to show the pump, this is a symbol circle and a horizontal line at the tangent at the top and tangent at the bottom shows the pump. So these are the simpler figures which shows the complicated figure of the pump. So instead of drawing the complicated figure of the pump, we have to show just this symbol to mention that it is a pump. So these are used to prepare the plan, service plan. As already I told you, there will be the working drawing. Working drawing means structural drawing. Structural drawing will be used by the construction engineer for construction of the building. Okay. Then after the building is constructed, we have to put the services, because without water supply, drainage and electrification, it is having no use. So we have to prepare the service plans for different types of services. Even in the modern buildings, there is a service plan for the fire extinguishers are there, service plan for the telecommunication is there, service plan for the CCTV network cameras also there. So that is for the advanced type of buildings. But basically, for simple building, simple house is there. At least we need these three basic requirements. Well, that is the water supply, drainage, and electrification. So these drawings will be helpful to civil engineers also. So he will come to know from the service plans. He will come to know where the conduits are to be provided, where there should be gap in the building. Suppose the exhaust fan is to be put, so at the place where exhaust fan is to be provided, he has to leave some gap for putting the fan, putting the conduit. Okay, so these service plans are also useful to the civil engineers, where he has to leave some cavities, because after at the construction stage, if the engineer has not provided the conduits or cavities, afterwards it is very, very difficult to create these cavities. There will be time consuming, and there will have the more additional cost for creating the cavities, particularly when the cavities are to be created in the RCC, reinforcement concrete. Okay, nowadays even in the kitchen, the chimneys for exhaust of the fumes from the cooking gas chimneys are to be provided. In that case, we have to provide the conduits, we have to provide the gaps in the RCC also. Otherwise, afterwards we have to create those gaps, and that will have the additional cost on the of the creating the conduits. So these are the different appliances which are to be shown in the service plans. Usually the working plan, then service plan, and then the foundation plan. Then some authorities demand for the terrace plan also. Okay, terrace plan are also submitted for the approval of the plans. So these are the different light power. Some of the these components you are also conversant with this. The fire alarm push, amplifier, control board, loudspeaker outlet. These are the symbols. And now we will come to this particularly civil engineering drawing, how to create the working drawing. Okay. So particularly for architectural drawing, we will have the working drawings, or also known as architectural drawing. In our previous session we have seen that at the bottom here you have to draw the plan, okay, and here you have to draw the elevation, and here we have to draw the section, and here there will be the before starting drawing you have to put the margins. On the left edge you have to put the margin of 4 centimeter, and for the remaining sides you have to leave the margin of 1 centimeter. So this is the layout we have already seen, okay. Now what is the plan? The plan is the top view. We can say it's the top view. Top view of the building which we are going to construct. It is not existing. We are going to construct it. And the top view of the building after cutting the building by a horizontal plane. We are cutting the building by a horizontal plane, and the horizontal plane is cutting the building at just above the sea level, and the top portion of that building we are keeping aside. Okay, we are imagining that we are removing that top portion aside, and then we are seeing from the top. Okay, then we are seeing the each and every point of the line which is visible from the top. Okay, so if we see the top view from only single point, in that case what will happen? A wall is there, the bottom of the wall will be at another point, and top of the wall will be at another point in the drawing. Okay. But in the orthographic drawing we are moving our eye above each and every point. So in orthographic drawing the bottom of the wall and top of the wall will occupy same point. For example, if a wall is there in orthographic drawing, so this wall after cutting at the sea level, so this is the top and bottom, both are occupying same point. But if I see this room from only single point, in that case what will happen? This will be visible like this. It will be having the 3D view. So this is the bottom and this is the top. Okay, this is the wall. This is seen from the single point. So this is the bottom of the wall, this is the top of the wall. Okay, so this is the projected view, and this is the orthographic view. In orthographic view we are not keeping our eye at the same point. We are moving our eye over each and every point of the line. Okay, line is will be there because of the change in the plane surface. Okay, there will be surfaces making the corners. Each and every corner will give us a one line. Okay, so we have to draw the orthographic. Drawings. Not the projected drawing. Projected drawings are not drawing here. So in working drawings we will be preparing the orthographic drawing. So here in this diagram you can see this is the plan of this building. So this is the isometric view. This is the isometric view of a room. This is room is having this. This is a plinth which is there, and a plinth. What is a plinth? We already discussed. Plinth is the level. Plinth level is the floor. At that level, the floor of this room is there, and that floor level is having the more height than the outer ground level. Ground level is having lower height, and this plinth is having the higher level. So this height may be varying from 30 centimeter to 45 centimeter. So from the ground, how you can enter in this? So they have provided this door here, and this height is more, so steps are provided. How many steps are there? There are 2 steps, one rise here, another rise is here, so 2 risers are there. So this is called the trade. Every step is vertical face of the step is called the rise, and horizontal surface of the step is known as the trade. So number of rises 2, so naturally trade will be 1. So always number of trade is rise minus 1, number of risers minus 1. So this is the weather shade. This is a weather shade. So we have imagined this is this building we are going to construct. Now to draw the working drawing of this, plan of this, we are cutting this building. We are cutting this building by this horizontal plane. Can you see this horizontal plane? This is the horizontal plane. We are cutting it. Okay, after cutting it, this building is separated in 2 parts. One part is the lower, below, and one part is this above. We are removing this upper part. This upper part is removed away. Now we are seeing this. Walls from above and how they will look. So we, after cutting, we get the edges. So edge will give the line. Okay, so this is the plan which will be available to us. You can see this how it is drawn. The plan is drawn like this. Okay, as I already told you, the material which is cut, okay, the type of material is shown by the material. So this is a brick masonry. The hatching of the brick masonries are shown here. So this is the isometric view, and for submission of the drawing we will be preparing the plan like this. Okay, so this is a one wall, another wall, third wall, and fourth wall, and then this is the door, and the one step, another step, and this is the weather shade. We, in local language, we call it as a chhajas. Okay, chhajas are the horizontal projection to prevent the door or inside environment from the sunlight and the rainfall. Okay, to prevent the doors and from this external agency. And this is a window, and this is the weather shade about the window. Okay, here it is written room, so it may be the bedroom sometimes, and this is the D for door. Okay, we already seen the abbreviation. Okay, for abbreviation D is drawn the drawer. So this is the detailing. This is the subtitle. Elevation. This is the elevation subtitle. So this is just this drawing, these 3 diagrams, 1, 2, 3. Okay, these are not the working drawings. These are to just explain you how the plan is drawn. Okay, to explain you how the plan is drawn, we have put this the isometric view of the room, and from this isometric view we first cut this building with this horizontal plane to have the plan. Okay, now next is the how to draw the section. For particularly section where we have to draw the section. Okay, section is the cutting plane. Along this line we are cutting this building. In this plan we have drawn the section line. Section line is drawn by a line dash line dash line dash. Okay, so this section line is along this section line we are cutting the building with a vertical plane. So this is the vertical plane. This vertical plane we are cutting the building. Now in this section line this arrow is written. So this arrow has got the importance. So direction of the arrow is important. Now direction of the arrow is on the our right side. On the right side in this direction. That means we have to remove this part of the building. We have to imagine that we are removing this part of the building. Which part of the building? The part of the building which is opposite to the arrow. This is the direction of the arrow. And what is the opposite of the arrow? This portion is the opposite of the arrow. We are removing it. And then we are seeing this portion which is now existing. This is the portion which we are not removing. And this is the portion which we are seeing from left to right. Our eye will be moving from left to right, and what is visible to us, that we will be drawing as a section. Okay, so in next diagram we will see how this section is drawn. Okay, you see this here, the room which we have cut with the help of the vertical plane. This is a vertical plane, we have cut this vertical plane, and the portion which is opposite, this portion is opposite the arrow. This is the arrow direction, and this portion is opposite of the arrow direction. Okay, so that portion we have removed, and then we have drawn from left to right. Okay, this is very important. If you remove this portion and you see from this left to right, that will not be in correct view, that will be incorrect view, because direction of arrow is this direction. If arrow direction is in this direction, opposite direction, in that case this will be the left direction. Okay, so door will not be in this side, it will be appear on this side. Okay, so direction of arrow is important. Now you may notice, let us go to our previous slide. This is our previous slide. Now you will see the plan gives us the horizontal dimensions only. You can see this horizontal dimension. If you know the scale of this drawing, okay, if the scale is say 1 centimeter equal to 100 centimeter, and suppose this is say 2 mm, so you can say this thickness of the wall is 20 centimeter. If this thickness is say 33 mm, so you can easily say this thickness of the wall is 30 centimeter. So this thickness is horizontal dimension, it is not the vertical dimension. Similarly, size of the room, suppose you measure this dimension is 3 centimeters, so you will say this width of the room is 3 meter. Similarly, this length of the room, if you measure with the help of a scale, it is 5 centimeter, so it is equal to 5 meter. That is also horizontal dimension. So the object of saying is that in plan we can only read the horizontal dimensions, not vertical dimensions. What is the height of this wall? We cannot say. What is the height of this door? We cannot say. What is the height of this window? We cannot say. So for all horizontal dimensions, plan is useful, but for vertical dimensions, we are drawing this sectional view. We are selecting this section. So location of this section line is important. Instead of drawing the section line here, if I put the section line here in this line, if I put the section line here, then in this section view I will not be able to have the dimension of the window, vertical dimension of window, vertical dimension of the door. Okay, so our purpose is not served. So how we should select the section line, that is very important. Section line should be selected in such a way that we should be able to convey, the vertical dimension to other person. Any person, any engineer should be able to know each and every vertical dimension of the building. Okay, sometimes only single section may not be able to convey all the vertical dimension. In that case, we may have more than one vertical sections. Okay, or may have the two vertical section in this direction, another vertical section in another direction. So at least vertical section should pass through important components of the building. Like this window is important component, so we are passing this from the window, then this door. Okay, particularly for this type of structure, single room, is single vertical section is sufficient to convey the all vertical dimensions. So these are the schedule of doors and windows. We will discuss later. And this is the line plan. Now before drawing the preparing the working drawings, if a client comes to civil engineer with some land area where he wants to construct his house, okay, then civil engineer will prepare the working drawings, but before starting the working drawings, the client has to approve the relative location of different rooms. So planner or architect or civil engineer will first collect the data from the client. What is his requirement? What is the size of the land? How many number of persons are going to use it? Then what are their requirements? How many rooms they need? How many number of floors they need? Then according to their requirement, the civil engineers will prepare the line plans. Not only a single line plan, he will prepare several line plans, and he will show the line plans to his client and get his approval. Suppose this is a simple line plan, and there will be different line plans for the same data for the same client. So then client has to choose. He will discuss the pros and cons of each and every line plan. What are the benefits? Then after the client has selected any particular line plan, then this line plan is to be converted into the working drawings, and those working drawings after completion are to be sent to the proper authorities for approval. Once approval is received, then construction is to be started, and before construction is to be started, the structural design of each and every component is to be prepared by a structural engineer, and at the same time what will be the estimated cost of the construction, that is also to be prepared by the approved valuer of the building. And sometimes if the interior design or interior decoration is to be done, then these drawings will be also useful to the architect, who will prepare the interior decoration showing all the furniture layouts. So line plan is the first step of before creating the working drawings. We have to prepare the line plans, and once the line plan is finalized, then we have to start with the working plan. Now you see this line plan, the walls are shown by a single very thin line. That means we are assuming the thickness of the wall is 0, and we are decided this bedroom should have the size of 3 meter by 4 meter. Okay, then this kitchen, so this 3 meter by 4 meter is the net area excluding the thickness of the wall. So when we prepare the working drawing, we will add the thickness of the wall. So actual length of this side will be more than which is appear here. So actual length of this side, always in any drawing, this first dimension 3 meter is horizontal dimension, and second dimension, this 4 meter, is always a vertical dimension. So how we can calculate what will be the length of this line? This will be 3 meter plus 3 meter and plus 1.6 meter. So it will be 7.6 meter. So 7.6 meter length is there, which is excluding the wall. So when you will prepare the working drawing, this length of this side will be more. Okay, so if you are providing this thickness of wall is equal to 20 centimeter, 20 centimeter, 20 centimeter and 20 centimeter. So total thickness of the wall is 20, 20, 20 and 20. It is 80 centimeter. It means 0.8 meter. So 7.6 meter plus 0.8 meter. So length of this side will become 8.4 meter. So while preparing the line plan, we approximately decide this size of the room. While preparing the working drawings, there may be slight variation of this size. Slight variation means maybe a variation of 10 centimeter to 20 centimeter variation may happen, because the reason is there will be restriction of construction of this building line. Okay, the authorities may not permit to cross the building line, construction beyond permitted area. So in any land we have to leave some margin spaces. Suppose this is a land area available to us, so some margin we have to leave, and then we have to, we cannot construct the structure in this margin area. So in the line plan and in the working plan there may be slight difference. So then after preparing this line plan, the first thing is we have to locate the doors and windows. Where you will provide the doors and windows, what is the optimum location for deciding the openings. We have to follow the principles of planning. Okay, so doors and windows are useful for the ventilation purpose and lighting purpose. Doors are useful for the movement of the persons, that is called the circulation between the rooms and circulation from the outside to inside. So naturally this is the veranda. You will have this steps here because the ground is having the lower level. Using this step, person will enter here, and from this space he can enter here. So you may provide door here, then another door here, another door here. You may provide drawing room. Okay, then the size of the doors, the main door will have the maximum width. Okay, then internal doors may have lesser width, and this WC and bath, the width may be very less as per the, because the size of the room is also, the WC bath is very less. Okay, so size of this WC is 1.2, this is the width, and this vertical size of the WC is 1 meter. In drawing room you may provide the door width of 1.5 meter, but here you cannot provide the 1.5 meter door. Okay, the 1 meter is the width of the WC, so it should be either 0.8 or 0.9 meter. Okay, so then after completing the line plan, we have to complete this. This is how the openings are shown. Already I told you this first dimension is always horizontal dimension, second dimension is always vertical dimensions. Then this we have shown all the doors with the D. This O is for opening. The opening is there, door is not provided, just opening is there. So the doors having the same size are shown, this D2, all these D2s are having the same size. Similarly this D3 is provided at the WC and bath, they are having this lesser size. Similarly this window, all these windows are having the W2 size, that means all these windows are having the same size. The scale is written here, 1 centimeter equal to 1 meter. Usually students are advised to draw the line plan on the graph paper with the scale of 1 centimeter equal to 1 meter, because in graph paper the horizontal and vertical lines are spaced at the spacing is 1 millimeter. So 1 millimeter represents the 10 centimeter in the scale of 1 centimeter equal to 1 meter. So that will be very convenient to draw these line plans on the graph paper. So for given data, students may prepare 4 to 5, 6 different line plans and then get it approved from this teacher, and then particularly the approved plan is developed into the working plan, that is called the wall plan. Instead of the lines we will show the walls. Okay, that's called the wall plan. So this is how this selection of the walls. Usually this partition walls, that means the walls provided for the WC and bathroom, where the span, the width and length of the room is space is very less, we may provide the partition wall. So 10 centimeter walls are not supposed to take the load of the roof, so they are known as the partition walls. And these are known as partition. 10 centimeter wall is called the half brick wall, and 20 centimeter brick wall thickness of the wall, if it is 20 centimeter, then it's called the one brick wall. If it is 30 centimeter, it's a 1.5 brick wall. Okay, so external walls should have more thickness, and the internal walls can be provided of a less thickness. So external walls should be provided of 30 centimeter thickness, and internal walls can be provided of the 20 centimeter thickness, and the partition walls are to be provided with the 10 centimeter thickness. If you provide all the walls of 30 centimeter thickness, then we are wasting our useful land area, floor area, in the thickness of the wall where it is not required. So we have to select the appropriate thickness of the wall for different types of walls. So you can see in this plan, this size of the room is very large. Okay, so 30 centimeter, 20 is enough, because 20 centimeter can support the load of the slab roof coming over there. But here you can see this, the space size is very less. Okay, so this wall, these 4 walls can support the load of the slab, and these walls can be treated as a partition wall. Similarly, this wall also can be treated as partition wall, but this is the external wall, so we should provide it of the 30 centimeter thickness. Okay, it is not always necessary that external walls should be of the 30 centimeter thickness. We can go for the 20 centimeter. For all the walls we can go for the 20 centimeter, the walls which are going to take the load of the slab, because reducing the size of the thickness of the wall will reduce the cost of the structure. So these are the different plans. The one room, single room is there, 5 meter, 4 meter. After considering the wall thickness, the external dimension of this room will be 5.6 and 4.6, because wall thickness is equal to 30 centimeter. Here also these rooms are there, and this wall thickness are there. Okay, these are, we will come there again, but before coming to that, I will show you how to draw the section. You see, this is a plan. Okay, this is a plan developed. First is line plan is developed. From the line plan, this elevation is drawn. So how to draw the elevation? Elevation is drawn first. After completing the plan, what you have to do, you draw the horizontal lines here, line for the ground, then line, horizontal line for the plane, and that you extend from here to this end, because these lines, horizontal lines, will be useful for completing the elevation as well as section. So similarly, the sill level, that also you transfer the line throughout, but you draw it with very light darkness. Okay, because afterwards some portion of those lines you will need to erase them. Okay, so this is the bottom of the lintel, and then the top of the lintel, then the bottom of the slab line will be there, and then the top of the slab line will be, horizontal line will be there. Then this is the, after the slab roof, parapet is provided, and thickness of the parapet wall may not be very large, thick. It will be lesser, thickness will be lesser than the thickness here. So this is the top of the parapet. Okay, that horizontal line you can draw. Okay, so after completing all these horizontal lines, you can have the corners here. Okay, one corner, another corner. Okay, these corners give you the vertical lines in elevation. All these corners you see, all these corners give you the vertical lines. Okay, so from these points you have to draw the vertical lines. Okay, this corner gives you this edge, this vertical line. This corner gives you this vertical line from bottom to top. Similarly, this corner also gives you the vertical line from this bottom to top. Similarly, this vertical line from this end of the window, okay, left vertical edge of the window gives this vertical line, okay. So next, after completing this elevation, you need to draw the section. For completing the section, you have got this section line. As already I told you how to select the section line. Section line should pass through important components of the building. You see, we have selected this section, and it is passing through steps, then veranda, then door. Again, there is a change in the location of the vertical section, and it's passing through this window and weather shade. So this section gives you all the vertical dimensions of all the components. So there is no need to have another section, either horizontal or vertical, correct? Either in this direction, vertical section in this direction, or in this direction. This is not required. Only this single sectional elevation is sufficient to give us all the vertical dimensions. So this vertical section gives us dimensions of all these details. You see the foundation, this is the foundation concrete, how much deep we have to do the excavation, what is the thickness of the concrete, then how these layers, what is the thickness of each and every layer, okay, how deep it is going. So this is the veranda wall, because here also we need the wall, because otherwise if you do not provide the wall here, this soil, because this height of this flooring is higher than this ground level, it's called the plinth height, okay. So this soil has to be confined between the walls. So this soil is confined between these four walls. One wall is there. These are the three walls. Some students are mistaken that this is the veranda, so why we should have the wall here? But actually this wall is constructed up to the plinth height. Okay, beyond plinth we we discontinue the construction of this wall, which we may call as a dwarf wall or low height wall. Okay, so this purpose of this wall is to confine the soil in this, so that the flooring can be laid. Otherwise what will happen, there will be if these walls are not there, there will be settlement of the flooring here. Okay, so from this point we have to go inside this, so we need these steps. 2 steps are provided, and one riser, trade, rise, trade. Okay, and then this detailing of the floorings are to be provided. Suppose it is say 60 centimeters there, so the top layer is the tiles. Tiles may be the vitrified tile, it may be the mosaic tiles, it may be the ceramic tiles, or it may be the stone slab, it may be quota stone or marble will be there. So depending upon the size, it varies from 2.5 centimeter to 3 centimeter, and beneath that, below that layer of the tiles, a thin layer of the mortar is laid. That thin layer of mortar may vary the 2 centimeter to 3 centimeter thickness of that, and beneath that a concrete layer, lean concrete. Lean concrete means having less cement content is laid. A concrete is there. Okay, beneath that the soil filling is there. So we have to calculate what will be the thickness of the soil filling here. So 2.5 centimeter thickness of the flooring, 2.5 centimeter the cement mortar, that is the 5 centimeter, then 15 centimeter concreting. So 15 plus 5 is equal to 20. So 20 centimeter is fixed, and total height is 60 centimeter. So soil filling will be equal to 60 minus 20, that is equal to 40 centimeter. So 40 centimeter soil filling will be there. Okay, so similarly here also this door is shown, the lintel is there. Sometimes here at this plinth level the DPC is also provided. You may show the damp proof course. The DPC is provided to prevent the damp moisture which is there in the soil, that rises in the walls due to the capillary, and that comes into this wall, and that moisture is affecting this the outer surface of the wall. Okay, that outer surface of the wall, the color is destroyed by this moisture, and sometimes this plaster is also deteriorated by this moisture. To prevent the moisture rise in this wall, this barrier, impervious barrier layer, is laid on the top of the wall. That is called the DPC, damp proof course. Okay, that DPC may be consisting the synthetic filament, maybe the bitumen. Sometimes they lay the concrete. They call it plinth level lintel. Okay, that is also sometimes structural strength of the building is increased because of this DPC. Similarly, this lintel and weather shed both are molded or constructed monolithically together. So laying of the concrete in this weather shed and this lintel is simultaneous. So let me tell you what is the lintel. Lintel is a beam. Lintel is a beam. This is the lintel. It takes the weight of this slab. Sorry, not slab, but is a masonry. Okay, in this door or window, exactly above this opening, the masonry is there. Okay, so this masonry weight, if this beam is not provided, that load of masonry will come on the door, and then the deformation or deshaping of these doors and windows may happen. So to prevent that, we have to provide the lintel and this weather shed and this then this lintel, some bearing is to be provided. So you see this lintel, some bearing is provided here. Okay, so width of this weather shed is slightly more than this width of the window. Okay, that is the reason. Now when we cut this plan building with a horizontal plane, the objects or line edges which are below that, they are shown by full line, but edges which are above that, above cutting plane, they are drawn by dotted line. You see, this is drawn by dotted line. This weather shed is above cutting plane, it is shown by dotted line. Okay, sometimes we may provide the beam. Okay, so the center line of beam is to be provided. So center line of beam should not be, the end supports of beam should not be above the opening. Okay, that we have to take care of it. So this is how we can prepare the working drawings, plan, section and elevation. Okay, the schedule of doors and windows to be drawing. So we have in this today's lecture, we started with the different symbols and how these different symbols are used in the developing the plan, section and elevation. So what is the procedure? First we have to develop the line plan as per requirement of our client, and once the client is selecting particular line plan, we have to develop that line plan. We have to convert that line plan into the wall plan, or we can sell the working drawings for submission to the authority for taking the permission of the construction. And those same working drawings are also useful to the structural engineer for designing the different components, is also useful to the plumbers for laying the water supply drainage lines, and then it's useful to electrician for preparing the laying the electrification, and also useful to the interior designer to have the furniture layout and interior designing various components. So that's the end of all this chapter, building planning. I hope this will be very useful to you from the academic point of view as well as in your professional life also. Thank you. Wish you best luck.